she has been taking up a hobby, I'm not sure for how long, of dancing with hula hoops. You look carefully, you might even see some of those hula hoops. So everyone, please welcome Reenah. There are your hula hoops. Everyone, that's awesome. Everyone, a big round of applause for Reenah. Take it away.
Thank you, Jared. Okay, so hi everybody, I'm Reenah, and I'm going to be talking today on A/B testing of your data science solution, how we can prove their actual value in real money or whatever it is that you're measuring in the company, clicks, installs, impression, or whatnot. Yeah, so I think you've all seen like this picture or variant of it. How the front end looks versus to the back end, how the front end is all beautiful with happy bunnies and rainbows, and the back end looks not as nice. I think that very much applies for actually experiments. The front end experiment methodology is so firm, is so well designed, is so well applied, while testing back end features, which are also includes data science models, is not very much, it doesn't get much attention it's deserved. And I don't think it's very much, it's not applied very well in a lot of places that I've seen, and very not well designed. So I'm here today to talk about how we can test backend features. So just to be clear on what I'm talking about when I'm saying front end, basically front end is everything that is visual to the user. It may be color, it may be text, it may be the structure of the website, of the page. And then we have the split testing, of course, that I'm sure you're all familiar with, that we choose a treatment group, we sample % of the traffic, and then we split them into two. Some see version A and some are exposed to version B. And at the end, we compare clicks, install, or whatnot. And if we have a significant difference, then we succeeded in our experiment. So that's all good and nice for anything that relates to the front end. But what about stuff that don't actually relate to front end, and we are not necessarily have front end? For example, queue routing. If we have a system, one of my clients, they had a system for queue routing. They had chat bots. It's not only bots, also agents. And they wanted to redirect the clients into the queue or have a smarter routing. How do we test that? Or, for example, item linking and categorization. If we want to change the entire linking of items in our website or design a new category tree, it's like too hard to split the traffic and test it. Like you need to duplicate the tree and whatnot. It's not even cost beneficial. And then like other simple models, even like just a new clustering algorithm that you apply that may affect some feature that eventually affect a recommendation for the client. How do you actually isolate the value for that model? Yeah, so this is like a sneak peek to what we're going to be talking about today. So the actual agenda is first why we even want to experiment. That's important to understand the motivation. I'm sure you all do. And then experiment design, how we actually want to do it, and then highlights and best practices of experiments. Okay, so why we experiment? I'm sure you all know or been a part of a discussion of the difference between causation and correlation. So I'm going to do it really brief, but correlation is the measure of how variables are related to one another. For example, I think the most famous example, sales of sunglasses and sales of ice cream. They are both very correlated, but obviously they are affected from a third factor. And sometimes variables may be correlated and not necessarily a third factor, but a combination of other factors. And we don't even know what they are, but we just know a trend. And that's not good for us. What we want to do in terms of experiment, we want a causation, a relationship. We want to understand the relationship between cause and effect. And guess what? Experiments are basically the best way to have this type of inference, to infer for inferring causal relationships. So that is basically the main reason. So if we want, we want to say that money comes in because we did X, because our model, we released the model, and then we know that as a result, we increase the profit of the company, or we get more clicks or whatnot. We want to have that type of relationship. Okay. And then how, the most interesting part, how we do that experimental design. Okay, so regular experiments, as you've all known, they include hypotheses, right? We have the alternative A and alternative B, and we want to compare them and how and which one is better. We define our population. Usually, if it's front end, it's users, probably percent of the traffic. We have our matrices. It can be few of them, but we definitely want to have a main one. And then we have our time frame. We define the window of the test, and we have the before time frame and the after, and we compare everything. Here you can see it maybe a little bit better. We choose a percent of the traffic. We do the split, and I'm not talking right now about how we split into groups, but it's kind of like a whole section later. And then we split into treatment and control group. And we track them both before the release. Basically, both of them are in a very same manner. They see the exact same version of the website or whatever it is that I'm testing. And then we release our feature and only to one group, and the other group remain untouched or a second version. And then we compare. So we compare the treatment group to before and after, and see their results, and then the control group before and after, and see the difference. And then we compare these differences and see if it was significant, if we had an increase. We hope there was an increase in the treatment group and a decrease in the control group, and then we can say the feature was successful. Yeah, but like we said before, what happened, the percent of traffic, it's not always possible. It's definitely not possible in many cases. And then what do we do? Examples. I mentioned it briefly before, but let's talk about it, like items recategorization. If I want to redesign the category tree in my website, like it's really hard to test it. If like split the traffic, it doesn't make sense, right? Because then I would need two category trees, and then one group goes to the older category tree and another group to the new category tree. And most of the sites, I don't think they can afford that, like duplicate their website. And we can think about a better method to do that. So for example, we can split the categories. If we create two distinct groups of categories, and they have to be distinct, and I'm going to touch that later, but we can imagine why, right? Because we want to isolate the impact, and we don't want people from one group go into another group, and then we won't be able to understand if it was the model that affected it or not. We kind of want it to be distinct. When we choose the categories, we want them to be similarly distributed. This is something that we need to elaborate a little bit on later, or even now, how do we create two groups that are similarly distributed? I actually have a slide on that, but it has to be let's start with the basic, about the same number of categories. They have to bring they have to hold about the same amount of items or amount of visit, depends what I'm measuring. And they probably want to bring same amount of traffic or money or whatever it is that I'm measuring. So the distribution has to be very similar. So at the end, I'm able to compare the results. So that about categorization. I can also approach it from the item level, not necessarily for recategorization, but if I'm changing the items, if I have the models that, let's say, change the item description or something else, or rerouting the items or linking it. So I can create two distinct groups of items. And then I'm actually converting the entire test from the traffic to the backend. And again, the group split here is very, very important. It has to be two similarly distributed groups, but it's possible. Another example is budget allocation. Let's say that I'm a company that manages campaigns, social media campaigns, and I have a new algorithm for budget allocation. So I want to understand how the new algorithm affects the campaign, right? I want to see more money coming in, more clicks. So how do I do that? Usually people tend to say slow release. So let's say I release the model only on one campaign, and then 5, and then 10, and then, I don't know, 50%. But I'm saying if you're already doing like a slow release, why not doing it smartly? Like sample from the beginning, like a few campaigns, and compare them to another group of campaigns that are similar. And then when you do the gradual release, you always have groups that you can compare and actually know that you have, let's say you didn't make any harm to your budget allocator, but hopefully you have increased some measures. So that's another way to split entities that are different than users. For queue routing, for example, for this company I was working with, they couldn't do that. They couldn't split the traffic at all, and they couldn't find any other solution, because when they apply the queue, they have to apply it for all users, no matter what. They cannot split anything, and they cannot split it gradually, and it was a problem. And I'll tell you in a sec how we solved it. But basically, my suggestion is you split other entities. You don't necessarily split the users. You choose another entity, hopefully the one that your model actually calculated. For example, if you're trying to optimize campaigns, so campaigns. If you're redirecting items, then items, and so on. And then you use the very same methodology here, which is very well designed and also it's well known and very easy to digest, and easy to prove also that we can list that money that came into the model. So all I'm suggesting here is to change the entity at the beginning of the test or the experiment. So like I said before, so in the categorization, we can have it on backend and also the budget allocator. The queue routing, we couldn't. Because we had to release it all at once. So, but even in like these extreme cases that we cannot find any other solution, there are, I call it creative split. When we split the days of the week. So for example, they had to to release the entire queue. So we had kind of a slow release. We took the treatment group we took 2 weeks time frame. And the even days at the first week and the odd days at the second week were the treatment group. So we kind of turned the feature back on and off each and every day. And at the end of these 2 weeks, we had 1 week as a treatment group and then a second week of a control group. We could have done it week after week, but it was too jumpy when we looked at the data before. Like the data had significant changes from week to week. So we decided to go like a day on and off. And it was actually really nice to see the value from that type of experiment. Yeah, so we said about like entity selection. So definitely define the test population. It can be items, it can be campaign, it can be the pages on your website, it can be anything, but it has to be like a very well-defined unit. The group split, which I'm going to be talking about in the next slide. And then we have the creative split, which is kind of a slow release, but it's a smart slow release. Yeah, and then going directly to the highlights. Okay, sampling methodologies, it's kind of a whole topic, and I think we can designate at least one, definitely we can fill in one talk just about sampling methodology or even a whole semester. But I'm just going to give the highlights here. I'm going to start with random versus stratified sampling. So for example, if I'm working at eBay and I'm going to be randomly sampling the website, the items on the website, I'm going to be having like, I don't know, 50% books, because they have a lot of books items, but no one cares about them because they care about electronics. Electronics sells the best. So what I would want to do there it's kind of a stratified sampling, right? Take each catalog and sample, let's say 100 items or 1,000 items from each catalog. And then that will create a stratified sample. And then here I want to talk about the practice of randomization, ensuring groups equivalent in composition. So how do we do that? So let's say I'm creating these two groups of items, and I want to consider the target KPIs as clicked. So I'm taking these two groups of items, and I'm measuring the clicks in each group. And we start with one group, and I'm looking at all the clicks, and then I sample it by the clicks. Or I can sample it by clicks and impression, or I can have it like 2-dimensional, 3-dimensional, or whatnot. So the groups are, the distribution is very much similar in each one of these features that I just selected. So that's a way to split the groups in kind of a similarly distributed manner. Another thing to sample, like I said before, it's days of the week. We can sample like even on odd days. Sometimes we do week after week. So that's another type of sampling as well. And then like kind of the million-dollar question that I'm always getting, it's like the sample size. So I just want to say there are sampling calculators that if you define the margin of error and confidence level, so you can pretty easily calculate what's the best sample size. I added here like a cheat sheet if you guys remember, like I know, like statistical classes, we can calculate the sample size basically pretty easily. So you can calculate the sample size for every margin of error and confidence level you choose. And then other important consideration, it's actually kind of funny how conflicts, like very basic, stupid conflicts in the company may hurt the experiment. For example, if I release something and I did like kind of a backend experiment, and then another guy from a different department had another release at the very same date. Now, if I had my group splitted correctly, it shouldn't affect that much, but still, I want to keep a clean environment. So you can like control it with kind of product announcement, or like just, you know, have like a calendar in your company about experiment. That's kind of the right way to go, but definitely communicate with other people in your company to understand that you're not both experimenting at the very same time. Another thing that I saw that is very, very interesting, that you have to really define the KPI formula. It's very different when you measure it on user and then when you measure it on item, right? It's a little bit different. And then what's the right formula? And then you can have it significant in one formula and then not insignificant, and then insignificant in another way you calculate it. So you definitely want to define it before you take before you start the experiment. Other effects that may happen, it's kind of a network effect that's mainly in social media, and this is something we have to analyze in advance, see how users interact with one another on our platform. If that happens, we definitely want to take that into consideration, maybe analyze the sender and receiver separately, or again, create distinct groups. This is like an issue that we need to understand how to work with. And then cannibalism effect that of campaigns. For example, if I do, let's say I do 2 groups of campaigns, there may be that the good group, that the one that has my models on, kind of attract all the traffic from other campaigns. And then that's not really fair game, right? So I need to think what to do there as well. We need to consider everything and analyze our data before. That's it. I hope I convinced you of like at least exploring some ways to testing your data science models and improve their values. Thank you. Thank you very much.
Thank you, Reenah. That was terrific. A/B testing is a very popular topic. I know that at the meetup and at the conference, we've had multiple A/B testing talks because it's so important. If you go to rstats.ai, there's actually a video tab, and you can see all the past year's videos. That's 6 years of NYR and 3 years of rGov.